Hello everyone, this is hopefully the first of a series of videos we're going to do over the next wee while, looking at the third year Nat 5 course and the angles and circles unit within it. This is a very strange scenario that we find ourselves in. This is the first home learning video I've done, so hopefully it works okay, and let me know if there's anything you want me to do differently. With the angles and circles part of the third year course, um, shift that out of the way. With the angles and circles part of the third year course, there is four learning outcomes we're going to look at. The first one looking at identifying isosceles triangles within a circle, and that's the video we're doing just now. I'll then do another video for finding right angled triangles in a circle and um, using Pythagoras' theorem to help solve problems. That's quite a common Nat 5 exam question. The third video I'll do is to do with right angled triangles in a circle and angle problems. And then the fourth and final video that I'll do is to do with tangents to circles. And it's sort of the angular relationship to the radius. I'll probably do that in two separate videos. Um, So as I say, this video that we're looking at is going to be to do with isosceles triangles within a circle and solving angle problems using them. So here I've got a circle on the left hand side here, and I'm going to do a couple of wee drawings on here for you. So first of all, I'm going to start by drawing in a radius line. Okay, and then from that I'm going to draw a chord line. Okay, so remember, a chord line is any line through the circle that doesn't go through the centre. The one that does go through the centre is the diameter, remember. And then I'm going to make it a triangle by putting on another radius line here. Well, pretty much by definition, because this angle, because this side and this side are both radii of the circle, then they must be the same length. And a triangle that has two sides the same length must be isosceles. So therefore, this angle here and this angle here must be the same size. Okay, so what we can do, what we're saying here really is that when two radii in a chord form a triangle in a circle, the triangle is always going to be isosceles. And so the angles here, basically what we're doing is saying that angle OAB and angle OBA are equal. Okay, so we're going to use that property to solve some angle problems just shortly. Alright, I'll show you some examples. So, find the missing angles in this diagram. So this one's pretty box standard. The first two we do are box standard. Will help you revise your knowledge of isosceles triangles in that sense anyway. The first thing to remember is that obviously for an isosceles triangle, two angles are the same and all three angles have to add up to 180 degrees, as with the case with every triangle. Now, in these sorts of questions, you have to identify the isosceles triangle yourself. So it's worthwhile just noting to yourself, right, hang on a wee minute, there's a radius line, there's a radius line, so those two must be the same size. And just confirm to yourself every time that you've got a right angled triangle there. Sorry, not a right, an isosceles triangle. So just confirm. It's useful to get in the habit of just confirming that to yourself. Okay. So if I want to find the missing angles, well, straight away I know that this one has to be 25 degrees. Right? And then to find the angle at the centre of the circle here, then all I need to do is 180 take away 25, take away 25. So that's 180 take away 50 is 130 degrees. And that's what that is. Okay, So nice and straightforward, okay? Just the steps really are confirm the isosceles triangle and then choose your strategy for finding the missing angles. Let's have a look at this one. This one's kind of similar, but this time what I've done is given you the angle at the top here. So how do we find, we know these two are the same size, but how do we find them? Well, if we take away 105 from 180, right, then what we get is 75 degrees. So basically we know that these two angles must add up to 75, and we know that they're both the same. So the last step is to take half of 75. Okay, and if you do that, you get 37.5 degrees. Okay, now realistically, you're maybe more likely to get one like this. You have to really think about the problem that you're faced and think about all the different things that you know about isosceles triangles within the circle. So if you take a wee look at this one, right? Again, just go through that first step with yourself, right? Where are the isosceles triangles here? Let's confirm them. Look for radius lines, right? So that's basically any lines coming out of the centre of the circle are going to be radius lines. So that triangle and that triangle are isosceles, but so is this one. So actually all three, because we've got three radii, then we've got three isosceles triangles. Obviously different sized isosceles triangles, but three isosceles triangles nonetheless. Now, let's start. It's up to you where you start really with this scenario. You can the only triangle you can't start in is this one at the bottom here, because the one at the bottom doesn't have any information in it, and you've not really got any surefire way of working out the angles in it until you've worked out some of the other ones first. So the bottom one you will need to leave to last, but the left hand side and right hand side isosceles triangles you can do either of them in any order. So let's start with the one on the right, okay? Well, it's an isosceles triangle and we've got the angle at the top. So we're going to do 180, take away 114, okay? And that comes to 66 degrees. And then we need to take 66 degrees and split that in half and get 33 degrees. And that's what each of these are. Now, I strongly suggest when you're doing this task in your jotters, sketch the diagrams out, because with a sketch of the diagrams you can put your working at the side and put your solutions, put your answers inside the picture, right? And then it makes it nice and clear for an examiner, or even just for me, to look at your diagram and go, yeah, they've got this right. Does the working they've got round about the outside confirm it, and is it valid? But at least I can see inside the circle that you've got the right answers. So 33 and 33 degrees there. Now move on to the triangle on the left hand side here. Again, we know it's isosceles and we know this one's 53 degrees. So we know straight away that this one is 53 degrees as well. So let's go on and find the angle at the top. Well, 53 and 53 is 106. So 180 take away 106 is 74 degrees. Right? Now, what you need to do next is try and work out the angles in the lower triangle here. Well, we know it's an isosceles triangle. We know that these two at the bottom here are going to be the same, but we can't work them out unless we know what the angle at the top is. Now, what you're going to find is in a lot of these exercises, you're going to be using angle properties that you've learnt about in first and second year to help solve these ones. And what you're seeing here is three angles around a point, 74, 114, and then if we take those two angles away from 360, then we're going to get the angle at the top here. So another bit of working, we do 360, take away 74, take away 114. and that comes to 172 degrees. Right? Well, that's nice and easy. What that means is that these two bottom angles add up to 8 degrees, split them in two, and these are going to have to be 4 degrees each. So pretty small. Um, it's a pretty small triangle, and that's us filled them all in. Now, if you were wondering and you were just wanting to confirm that you had really done everything right, that this triangle was indeed sort of valid, one of the things you might do, you might notice that around the outside is a large triangle, and that large triangle is made up of the three smaller isosceles triangles. Now what you could do is add up 53 and 33, 53 and 4, 4 and 33. And those six angles should add up to 180, the angles in a triangle. And I can tell you now that they do, but in a problem like this, if you spot things like that, you think, well, if that was the case, then if I've done this right, then those three angles should add up to 180. These are things that you can do just to give yourself a wee check, keep yourself right. So, given all of that, hopefully you found that okay. I'd now ask you to go and do exercise 10.6, just question 2 and question 3 from your book. The rest of exercise 10.6, question 4 onwards, to do with Pythagoras and circles, and that's for the next video. Okay, and I hope you found that useful. Let us know if, again, if there's anything you want me to do differently. And you guys get the pleasure of being my first video lesson.